Okay, in this video, we're going to talk all about solutions. And a solution isn't an answer to a problem. It's going to be a mixture that is dissolved in water. Yes, okay, so we're going to talk about our lovely water molecules again. And remember, our water molecules have this lovely bent or angular shape with our lone pairs over here. And as we went over in the beginning of all these videos, okay, there's a partial positive and a partial negative region. So that means that water is polar. It's going to have the negative end over here and the positive end over here. And it is going to make a variety of things fall into solution. Okay, so one of the things that we always start talking about is if you go to a restaurant and you order some iced tea and it's not sweet, how do you sweeten it?
Ah, well, that's easy, Miss Levin. All I do is I just take some sugar packets and I open them up and I dump them in. And then I mix, and then it's sweet.
But is it though? Is it actually sweet when you do that? When it is iced tea and you start dumping in sugar? The answer is no. If you make tea from scratch, like you actually brew the tea leaves, you have to sweeten it when it is hot tea because the sugar dissolves in the hot tea. All right, if the sugar doesn't dissolve in the hot tea, it's not going to get sweet. So usually the sugar all sticks to the bottom of the container, and if you're drinking it with a straw, you like suck up the granulated sugar and it doesn't work. So how do Starbucks and Dunkin' Donuts and all those places get sweetened iced tea or iced coffee? They use liquid sugar. They use a dissolved sugar slurry, and they use that to pour in, and then they end up getting it sweet. Okay, so there are three major factors that affect how quickly things dissolve, and we're going to talk about them in terms of the water molecules. Okay, the first one is going to be increasing the surface area. The second is agitation, which is a fancy way for us to say stirring, to agitate. And the third is to heat the solvent. Okay, so first, increasing the surface area. So what that means is that you are going to spread out what is being dissolved. Okay, so again, remember, we have our water molecules that look like this. They have a positive end and they have a negative end. All right, what I want you to remember is that water molecules are piranhas. I think that's how you spell it. Okay, piranhas, those little fish that are so adorable. Okay, and they have these lovely little tails here, and they have these mouths with these teeth, and they are very, very mean because the way that they act is that they take and pick apart things. So that's exactly what the water molecules do. If you spread out, increase the surface area, you're going to see that they are going to pick apart your molecules a lot faster and pull them into solution. Okay, it will be a lot faster if they have granulated sugar than a sugar cube. All right, the reason for this is that there is more chances for the piranhas, the water molecules, to get to them. If it's one big cube, they have to pick apart a piece here, and a piece here, and a piece here, and a piece there. If you don't want to think of a piranha, think of water molecules like a flock of birds. All right, will birds pick apart bread or eat breadcrumbs or an entire loaf of bread faster? Well, breadcrumbs, because there's more spaces in the breadcrumbs than they would and have chances to attack the bread. All right, the second thing, which seems pretty obvious, is you are going to agitate or you are going to stir it. So if you added sugar okay, to two containers, all right, one of which you used a spoon to stir and the other you didn't, which one would dissolve faster? It's going to be the one that you stir, okay? So the reason why that works is because you are basically speeding up the water molecules. You're adding little jetpacks to the piranhas, and they are going to get at all the little sugar molecules a lot faster. All right, and the third factor is going to be heating your solvent. Okay, hot tea will dissolve sugar faster than iced tea. That's why on all of your beverages it says shake before drinking, because they want you to shake up and mix it all in there. Give it a little bit of energy, give it a little, good shook. All right, so what that means is you are basically also, you are going to speed up your water molecules, you're speeding up your piranhas, and these piranhas have jetpacks and they will be able to eat the food or, in this analogy, separate and pull your substances into solution a lot faster. All right, so this is what happens when you dissolve things. All right, if you have something ionic, if you have something that has a positive and negative region like salt, Na plus, Cl minus, the plussiness and minusness, the polar regions, so the negative region and the positive regions, will surround and pull it into solution. So here you see the negative regions attaching to the positive Na. Here you see the positive hydrogen region attaching to the chlorine and pull that into solution and pull that into solution until you get to a point where you have like the maximum amount of stuff in solution. So that means that you can end up having this equilibrium. And this equilibrium is when you have that maximum amount of your solute in solvent at that temperature. All right, so if you add any more of your solute, it would just stay on the bottom and it wouldn't be able to dissolve because it doesn't have an appropriate amount of water molecules to pull it into solution. And that is how water dissolves things. Don't forget, water molecules are the same as piranhas.